We're having these quite often lately. This is the fourth one this quarter from Qfensoft side, and we are lucky enough to have Milan Saylor from Ansys, who will be presenting today on our Ansys Minerva solution. But firstly, for those who are new and don't know us yet, so I'm Lara van Niekerk and I work for Qfensoft, and we are the sole suppliers of Ansys simulation software in Southern Africa. We have two offices. There's the head office in Irene, and then we have the one which is in Stellenbosch in the Western Cape region. And we are here really to support academics, industry, to really just drive human innovation. And today we're focusing on Minerva solution, as I said, and we have Milan Seder from Ansys, who will be covering the session for us. He's based in Germany, so really warm welcome to you, Milan, and thanks for the time in taking us through your presentation. So I'll hand over to you. Thanks a lot.
Thanks. Thank you, Laura. Yeah, welcome everybody. Nice to talk to you about simulation, process, and data management today. As you can see, my LinkedIn QR code on the right-hand side, if you would like to see my history a bit more. So I'm coming from I'm a mechanical engineer doing a lot of software selling in the last year from a technical perspective, commercial perspective. So I have different roles in my career, and I'm more on the process side of things more rather than on the simulation side. So my background is more product lifecycle management and this kind of engineering focus. And that's the reason why I'm here today to talk to you about Ansys Minerva, because this is a simulation process and data management tool suite which changes the way how people are working inside simulations. So it's impacting processes, data storage, and everything else. So it's more a process-related solution rather than a feature function-driven solution, and that's the reason why my process background fits quite well. And Ansys hired me last year, March. So I'm more than a year with the company, again, with a lot of history in different domains of software cells. I'm not quite sure if you know Ansys, so I did not prepare an Ansys who we are slide deck because we want to talk about simulation data management. So, well, if you don't know Ansys, we are a simulation-based company existing since decades, to be honest. There are more than 6,000 employees right now and have a huge footprint in the simulation market. Seems to be number one solution provider for that domain. So simulation is our bread and butter business, and from our perspective, we see that the simulation topic is going on and will extend more and more. We are talking to a lot of customers about their future vision, and everybody is telling us that simulation is a hyperscaler for each company. It will become more and more. People see the benefits in doing early decision making processes and doing simulations rather than testing. To save money, you know, because as more as you can do in the beginning of a development phase, the less costs you have when you do changes, and simulation can help here to really validate whatever you do. So simulation is getting more and more, and Ansys, of course, is in the middle of it. But we can also see that doing more and more simulations, creating a lot of other issues around that topic. So not doing a simulation only is the key message here, but administrating everything around the simulation, the data, how to do it, where to do it, whom to do it, how to include other departments in my work, how to collaborate, how to manage my data. So all these topics around simulation itself is getting more and more important because more and more simulation is done, more data is created, more collaboration is needed. So how to deal with that problem? And what we can also see is that simulation tools itself, they are good, and more simulation is even better than less simulations to be done. But to really improve and create efficiency in your company, it's not only a matter of what kind of tool to use, because the tools are getting more and more equal, and the tool power is somehow limited. But companies recognize that the process story, so how to work together in a company between different departments, is getting crucial. So if I want to be better and getting better as a company, I should not only look at the tools, but also at the processes. So improving processes in my own company is giving me more and more advantages, and it's getting more and more crucial to be better and to optimize my processes, not only the tools. So this process story and data management topic is getting more and more important because of those reasons. So how to, what is the impact of that for my daily work? And there's a term called digital engineering, and which is coming more and more important here, and giving the answer on how to deal with those kind of problems, capturing my processes, getting around the data, and doing more and more simulations. So digital engineering is a different approach, means to connect things better. So 3 topics which are key here for digital engineering is to be able to shift left from a product development perspective, to say, okay, I want to apply simulation as early in the process as possible, to know as early as possible if my design and my work is going well or not, if I get issues in the following development cycle. So shift left is something which I would like to apply, and where digital engineering might help me. The digital thread in general. So the closer collaboration between engineering and simulation, which is probably the key aspect of digital engineering. So today we talk to a lot of customers, and they are still working in a manner that the engineering guys are sending something around to somebody else by email, pointing to some SharePoints and say, here is a new cut file, here's a work request, please do a simulation for me. So, and then they're getting back some reports, but it's all quite a manual, collaborative way of working, and it's some kind like a process of throwing something over the wall from engineering to simulation, and then it's throwing back. So it's not a real tight collaboration established in a lot of companies which we talk to. So that's establishing a digital thread between those parties is probably one of the key aspects of digital engineering, and which helps also to do more simulations, because we are getting more and more efficient if we have this digital thread established. And last topic, which is driven by digital engineering, is democratization. So automation of simulations, and also to provide simulation capabilities to non-CAE experts. So doing more simulation is fine, but if I don't have resources to do so, I can't help it. So I can be more efficient, so that one person is not wasting time for searching and finding any data, but just investing his time for simulation itself. So if he's getting more efficient, then this person can do more simulations, of course. But it's endless. It's this one person. So we have a lot of regions in the world where we have a lack of resources. So how to make sure that the more simulations can be performed by somebody? So it's getting more and more crucial to involve a lot of non-CAE experts into these simulation tasks. And that's called democratization, to make this available to non-CAE experts by putting a complex simulation in a new frame, and make it easy to use by just giving some parameters to be inputted, and then press the executed button, and then something is done in the background. So that's another topic of where digital engineering is helping to deal with a higher demand of doing simulations. So this whole story comes back to, at the end of the day, out to the product development process. And we can see that the product development process, which looks like this one mainly, I mean, of course, there are thousands of variants in this scenario, but at the end of the day, you're going from a requirements through a design phase to production and to support and services. So that's mainly it. So this product development process is as it is. The simulation process itself, which I would like to do, is a totally different process. So it does have different steps and different demands. So it's not fitting from a cycle point of view, duration point of view, task point of view, audience point of view, doesn't really fit to the product development process as such. But nevertheless, what I would like to do digital engineering, to do more simulations, to do a shift left, I want to do simulations in different areas of my product development process. So in the requirements phase, in the concept phase, in the primary design phase, optimization phase, in the testing phase, in the testing phase, I want to connect my test results with the simulation results to see, okay, is my simulation good? Is my testing good? Does it fit together? Do I have some issues here? So there are a lot of activity or sections within the product development process which I want to relate to the simulation process. And that's really, really difficult and, to be honest, nearly impossible to do it without any kind of tool support because, again, what I mentioned, there's a lot of data needed, a lot of collaboration needed in different stages. It's going back and forwards. It's an innovative process, which is inside here. So there needs to be some kind of a solution to help to get those arrows structured and administrated. So the approach, and in addition to that one, to get this arrows aligned, we have the simulation as such, the same process as you can see here, from gathering the data to post-processing and data archival. There are different issues here, so different locations for the different simulation steps, SharePoints, server environments, the local storages. I have different data and processes involved. I have project goals in the beginning and cut files I need here. I do need some meshing here, setup to do some automations and so on and so forth. So it's getting more and more complex. And what we can see today in those simulation processes or workflows, that there are siloed activities going on. Each simulation engineer is working by himself. We have a lot of companies who are having distributed simulation departments, once in India, once in South Africa, or in the US. So they're working in silos and they're just exchanging data on an occasional basis. So manual communication is needed here to keep everything together if you work in that way. We have a large number of simulation tools being used. So I have to find a way to structure all tools somehow in the same way, to not have a different process for different tools. A huge amount of data is generated. You know that simulation data files are much bigger than all the other files used for the product development process. So you have to find a good way to manage those. And yeah, the storage is ad hoc somewhere, just stored locally or whatever. Reuse is not possible because I'm not able to search for anything because I have no dedicated single source of truth. So governance, regulations is difficult to capture because I don't have described processes. So a lot of issues we can see alongside. So our view on how to solve it and how to create a connected digital thread here between the product development and the simulation side is following. So the product development process here, again, is captured by a lot of tools. So we can see requirements engineering tools in the beginning of the process, or the PLM, which is in the middle of everything, is having those requirements in their own environment. Then we can see ERP and manufacturing resource organization planning tools here. So a lot of tools being used in this one, and ECAD, 3D, application lifecycle management tools, electronic tools. So a lot of tools being used here. So that's our development process somehow to some degree. And the other side, I have the simulation tools being used from different companies for different purposes. So whatever you can imagine, and a lot of tools are missing here. So the idea now is how to bring those parties, the simulation level and the product development process together, so to work in a connected digital thread and to gain all those benefits which I need. So it's a glue, it's a simulation process and data management platform which sits in between. So this tool environment is a working environment for the simulation engineers and everybody else. We will see it in a following slide. So this is the party which captures our simulation process. So the way of working of today, or the new way of working we might want to have, is captured inside this platform in the middle. And then we are able to connect the simulation tools to this platform and connect our way of working with the simulation tools as such, and with the data which I need. Data like requirements. So we are able or you are able then to give those requirements which are valid for simulations to this platform backbone to say, okay, please, dear simulation engineer, make sure that those requirements are validated by the simulation. So that's the one part of it, how to connect it. And the other one is, of course, to connect to the PLM on the different stages. So within the concept phase, being connected, and as well as in the other phase. So this connection between my simulation process and data management platform and the PLM is established to really have a connected digital thread. So we are not talking to the 3D CAD systems, or ECAD systems could also be possible, but it's a better approach if you have a PLM system to talk directly to the PLM. If you don't have a PLM system in place, then of course there's a different approach, and it's still working somehow because you have a product development process. So there might be another tool than PLM being the exchange. But here it's a matter of exchanging it with a centralized source for the product development process. And we are exchanging data, reports, and we are also connecting processes with the PLM. So this is a connected digital thread here, which is established between those parties to bring the product development process and the simulation process together. And then we are able, then we are able also to connect all different other tools to this simulation backbone platform. Like, I don't know, we know customers using IBM Rational. We have material data libraries which we can connect, testing data libraries to connect the test data with the simulation data. We can connect to Microsoft Outlook. So we can sending emails around to create awareness in a broader audience. So there's something happening in the simulation process and data management platform. Please be aware. Here's a hyperlink. Go look. Or we can include the Microsoft Teams chat to the simulation process and data management. So the idea is really that everything which is needed and it's ongoing with regards to simulation is somehow triggered in this environment here. So that's the idea of this digital thread with SPDM in the middle of everything. So another view, how to establish this and what's needed to get there, and what kind of steps are done, and where's the value for that one. So if we see all the tools which I just mentioned before, PLM, requirements management, ALM, whatever, there's the SPDM part now being part of this whole setup. And there are challenges and the solutions which or stages which you have to follow. So to get to the digital thread, there are different stages to take. So the first stage is to get control of your data. So today we see that the data is stored in silos. It's not connected somehow. Nobody knows if the CAD file is really up to date, which I'm using for simulations, or if a new version exists. So I have to ask the engineer, or I hope that the engineer is asking or telling me, oh, I have a new version, but I'm not really certain. So I have to find a way to really get all the data I need, all the requirements, all the PDFs, Word files, whatever you need for describing, all the CAD files and everything else in a centralized environment to really, so the simulation methods to really and really manage them, version them, to collaborate and to search and reuse. So that's the first step, getting control of the data. And then we are able to answer those questions which you can see on the left-hand side. So how can we integrate the simulations faster and validate the decisions? How can we be traceable and so on? So that's the questions which we can answer here once we get the control of the data. And to be honest, even getting control of the data is giving a lot of benefits to a lot of companies we are working with, because they have no idea about the data. They're not able to reuse. So data management is a key aspect, the first aspect, and giving already a lot of benefits. The second part then, once you have the data finished and up and running, getting control of the process itself. So your workflows and business process. So this is helping you to deploy to non-experts, which I mentioned, to do optimization routines within your simulations, to simplify HPC, high performance computing and connectivities, to do automations. So for example, a lot of simulations are done in a sequence, first structural, then thermal or whatever. So there's a handover of data, there's a process which needs to be captured to have this kind of automation run. So that's possible from a process point of view to do, and the business workflows. So simulation engineers doing something, somebody has to validate it, somebody has to prove it, then it needs to be sent to somebody who is requesting it. So this is a workflow, a business process, which we can see, which we can capture with these kind of tools. So data, then we have the processes, which gives me the ability to answer these kind of questions. What kind of quality expectations do I have? What is the trade-offs and offset validation doing? And how can we accelerate the simulations? So that's the answers for that one. And once I've done all those steps, the last one is streamlining for efficiency, so called enterprise connectivity. So how to bring this whole story of the simulation process and data management, so the yellow platform from a slide before, connected to the outside world above the simulation tasks, so to the product development process tools. So connected to requirements, design specifications, and also then to really make sure that the continuous improvement process is started. So that's the way how to get to the digital thread and what kind of steps are needed. Once you've succeeded with everything, then you are somehow performed a first step of a digital transformation. So and Ansys Minerva would, or the SPDM solution will then be the single source of truth in the middle of everything. So once you achieve that one, you are able to get those kind of benefits which I mentioned here. So you are able to reduce the development cost by avoiding errors and use the right tools at the right time with the right data. So you are able to improve the productivity by centralizing all the data and not just storing the data, throwing it in a SharePoint, but really managing the data. So reusing it, analyzing the data, reviewing the data, comparing the data, and so on and so forth. Versioning the data so that you can see, oh, my PDF does have different versions. Do I use the latest one? And no more wasted time on rework. And even on search and reuse, we know that roughly one third of the time of a simulation engineer is occupied or wasted with search and reuse and gathering everything together before starting to simulate. So imagine you can reduce it to minutes instead of one third of your total time and spend it for more simulations afterwards. So huge benefits here. Drive innovation is much easier, of course. When you have a connected approach between engineering and simulation, then your cycles can be much shorter. Your exchange is much more controlled and efficient. So you're you can really be much faster here in your in your engineering work, and well, accelerate the product development at the end of the day. So that's the overview for Minerva as such and SPDM and why it should be used and what's there. Here now we are going a bit more into the details of the functionalities. So of course it's the positioning of Minerva which is important, and the value you can get. And now I'm talking about the functionalities. So in a nutshell, as a summary, those are the main functionalities that are simulation process and data management. You can also see in my title, I call it sometimes simulation lifecycle management, which it is. It's a product lifecycle which I have, and the simulation lifecycle, it's a different one. And that's the reason to have different tools which are connected in a good manner with each other. So these are those functionalities we have. We can manage the data. So again, the core and the first step to put all the data you have in one single source of truth, versioning them and make them available. Simulation process management, as mentioned already, to capture all the simulation processes, business processes, workflows as such. HPC is a functionality which is needed. So we are able to really administrator the HPC jobs and make life easier for the simulation engineers, so they don't have to care anymore. Dashboards and reports is something. So once all is automated, once you have all the data and once your processes are running through, it would be nice at the end of your simulation task to have a capability to create a report automatically out of your results. So not by putting some PowerPoints together, but just clicking a mouse button and see, okay, there's a PPT, a PowerPoint or PDF created, or an XML web page created which contains all the informations which are needed for the engineering guys to succeed or proceed. So that's something which is important. And dashboards here, the first part, it's the idea of user acceptance. So when you are a simulation engineer, you're working with this kind of tools, you're guided by a dashboard, which is your own dashboard showing your own task and creating more efficiency. And enterprise deployment. So we know a lot of customers of us are big customers with a lot of simulation entities around the world. So we have to make sure that we are able to give performance and user rights to all the audience across the world. So that needs to be is one important part here, and the enterprise integration as such. So PLM integration, CAD integration, requirements integration, process integration to Jira or IBM Doors or whatever. So these are those main bullets functionality-wise, which needs to be captured. And of course, it should be robust, open, configurable so that it can adapt your needs, because each customers are working differently. We always have to do this undiscover or discovery calls with the customer to understand their way of working, and then to see how a solution of SPDM could fit. And it should be comprehensive and on an open ecosystem. So enterprise integration is vital, because you never know what's happening. So if you buy a new simulation tool which needs to be connected to your simulation platform in the middle, then it should be possible without a lot of customization or development. So you want to have a tool which is easy adaptable, easy configurable, and easy extendable to all the different tools you might be using in the future. So that's one of the most key aspects, I would say. So therefore, Ansys Minerva as the SPDM solution stands in the middle and is a single source of truth for a couple of people working with it. So of course the CAE manager is connected to this SPDM solution, because he's getting all the simulation requests and distributed those requests to the simulation engineer. The simulation engineer itself, CAE analyst in that case, he's doing this daily work. So he got a task from the CA manager. Please do a simulation. Here's the data you need. Here's the time you have to spend. Please let me know once you're done. Then we have the CAD engineer, which might be interested about the simulation status, or might also be working directly in this SPDM solution, different scenarios, which we captured with the customers. The program and project manager is working within the SPDM solution, because he wants to know the status of the simulation task and of his project as such. So is it ready? Where is it? So instead of asking Friday, everybody, are you ready? Are you ready? Are you ready? He can look into the system and get them by a mouse click dashboard showing the status of all the different simulation tasks. Then we have the non-CAE expert or other requesters which can use the system to do some democratization task, like parameterized simulations, or just looking for some data which are stored here. And then we have method developments and IT admins. Those are the guys who are putting the processes and workflows inside this environment, saying that, okay, we have to add a new subsidiary in South Africa to our domain. So how to connect those people? Do we have to define a new workflow to embed it into the system? So that's the administrative task they do inside the system. So these are all the parties which are involved here in that domain. So let's go a bit more to the key capabilities which we have. A couple of ideas just for flashlighting. So simulation decision support, so to say. So really role-based dashboards and reports. We are able within the SPDM solution to capture different roles. So as you saw, program manager, CAD manager, CAE manager, CAE analyst, everybody has a different role in the company, and of course is using the tool in a different way. So it's if a CAE manager just enters the tool once a month, he probably just want to see less information when opening the tool because he wants to be guided to know what to do. So he might have a different view, like the CAE analyst, so the simulation engineer, who's really working with the tool on a daily basis. He needs another entry door to the system and much more functionality. So we can adapt the user roles inside the system to make it as efficient as possible for the different roles of the people. And again, at the end of the day, create automatic reports, which are then sent around the company to feed the other departments with informations. Data management as such, as mentioned a couple of times already, so we are able to store all the data, which you can imagine, inside our system. We are not only storing them, we are managing them. So we know which version they have, we know which version they had, we know we can search for everything. We are for all different kind of simulation tools which exist in the market, non-Ansys, Ansys, it doesn't matter. We are good in both ways. We can connect those tools to our environment. We understand all the informations inside of those tools. So for a MATLAB Simulink model, for example, once we are importing this MATLAB Simulink model into our platform, then we are analyzing the metadata. We are trying to understand everything which is vital for this file and storing everything together with the file. So it's not only a storing, it's a managing of the data. So that's what we can do. We can compare files, so CAD file version 1 with CAD file version 2, PDF version 1 with PDF version 2, whatever you want to compare. We are also able to do this in a quite intensive manner. We are working with a lot of partners together to create reports and visualization. So if you have an NX file or another CAD file, Creo, CATIA, whatever, inside your simulation environment because you need it for doing the simulations, we are able to preview these files automatically. So you don't have to jump to the CAD file to see what's in it, or you don't have to jump to the CAD file to compare CATIA version 1 with version 2 file. So we can do it all together inside this platform. And visualize everything. We can visualize MATLAB Simulink data so that you can see the results of the simulation being performed. Whatever you like to visualize, we are able to do it inside the environment, combined with the reporting functionality as mentioned, automatic PDF generation, generation, whatever is needed. Traceability, dependencies. So as soon as we have everything inside the system and we know what's going on, we are able to trace. So if you want to know the relationship of a file with another file, or a task of a simulation engineer with a file, or whatever kind of connection you like to identify, or a requirement. I see the requirement, I want to understand where this requirement is being used and what kind of simulation runs. Then all these kind of traceability questions can be answered by the system and being shown in these kind of traceability charts, which you can see in the animated picture. Then we can do configuration management for the file types. So we can manage the versions, and we can also manage the history of the files, so that you can really understand why do I have a new version, who's created it, how long does it exist already. So that's information we can see here on the data management topic. And we have a collaboration capabilities. So as mentioned, if you want to discuss something with somebody else. So the CAD engineer is giving you something, you're doing something in your simulation platform, and then you have a question back, or you are doing a thermal analysis based on a structure analysis which was done before, and you want to exchange something with your colleagues, then you can do this exchange directly inside the system. So all the discussions which you do, questions, oh, I didn't understand, what is there something missing, or why did you choose property A instead of B, or whatever the question you might have, you can collaborate and discuss it inside this environment. The good thing is, if you go to holiday, or if you are missing something, or if next year somebody's looking in the old work which was done a year before, then all the side documentation is also captured. So you really have a good understanding of what's going on and why something changed, because you can track the discussions ongoing. So that's something which we can do here. The other one, key capabilities for simulation applications and process management. We can adapt business processes as mentioned. So this is one example of a life cycle where you have a starting point, you submit something, you start to work with it, you complete the work, and you accept the results. So all these steps are performed by one or two or more people. So everybody's got a task and needs to complete the task and is giving the results back. So this is the way you are working today, which you can see here, which we are able to adapt to our system so that it's documented and can be followed by everybody. So imagine, as also often happening quite often, that new people coming on board and they have to be trained and they have to know how it's working, how you are working, or you have a new team somewhere abroad with a time zone difference, whatever. So hard communication parts. And you want to give them a guidance here, that's a process, just follow it. The system is doing everything for yourself. So you see what you do, just accept and do whatever you want. And then you say supply or submit or whatever. So this kind of business processes and workflows are stored inside the system and helping you and the others to work more efficiently because they don't have that much questions and they don't know exactly what to do. And you're storing your knowledge, which you have in the company, inside an environment, so that it's documented and cannot be lost when somebody might leave or whatever. Then the HPC topic as such. So we are able to run batch jobs. We are taking care of all the HPC jobs which need to be done. We are distributing them. You can assign priorities to it. So everything is automated by our environment. We can define tasks. So here you can see a list of tasks and the calendar, and you can assign the tasks and define the duration of those tasks. So it might take 5 days or 6 days. It should be done by colleague A, and this task should be done by colleague B and takes only 1 day. And this one needs to come before that one. So that's the way how you can structure your simulation work if it's getting more and more complex. So the bigger you are, the more simulation runs you have, the more dependencies you have among the simulation runs, then you can use this mechanism to really create a good understanding timetable and to know and define when the simulation might be finished. And here it's a way of connecting different tools. You can see those tools names here. So this is a flow of tools being used like an optimization routine. So take the NX design, go to Nastran, to Abacus, whatever tool, and do this kind of workflow process automatically, please. So we are able to put those kind of automatic processes into this SPDM platform solution so that it can be run automatically in the background. So this is described by a Python script or by a third-party tool. So whatever you need, this can be captured in our environment to do optimizations and workflow automations. Last but not least, these are the simulation app window within the SPDM platform, and you can see a lot of icons for a lot of tools. So we are able to connect all the different tools you can see here to our environment, and so you just have to click those icons here to access a tool or to access a Python script or whatever you want to connect to. So that's the view of a simulation engineer with all the tools he have. Of course, it's a lot of tools, so normally you just have a favorite list of tools which you use as a simulation engineer. So simulation engineer A might just see those 3 ones here because that's those for him, and the other ones are hidden. And the other simulation engineer logging into the same system does a different role, and he might see those 4 icons here instead of those 3 because that's his task. Yeah. One question.
I think, Ita, you can ask your question or you can put it in the chat.
Yeah, I take 5 more minutes and then we can jump to the Q&A session. if you want
Okay.
to wait.
Yeah, maybe carry on, then we go to the questions afterwards. Okay.
Finish. So we have then client connectors. So from the other side, so here simulation apps is our SPDM solution is connected to the outside world by accessing those apps. But we can also go the other way around, that from the tools as such, like Ansys Workbench, or even from a PLM point of view, or Microsoft Word, Excel, those tools can be connected to the SPDM from their perspective. So within Word, within Excel, within Ansys Workbench, whatever tool you like, you have an icon to be stored in Ansys Minerva. So that's the way we are also connecting to the outside world by providing these kind of integrations. And then my main story of today, in the beginning, the PLM connection to the Ansys Minerva SPDM connection. We are providing a lot of PLM connectors. So whatever kind of tool you're using on the left-hand side, PLM from Aras, from Siemens, from Dassault, from PTC, whatever, we are connecting to all of those. We have different PLM connectors for different tools to really be as open as possible and independent from the PLM system used by the customer. And we are exchanging CAD data with the PLM. We send the results and metrics back to the PLM system. So this is all configurable and customizable and can be adapted to your needs. And we also can adapt to different kind of implementations. So we have a push principle. So the PLM system can push data to the SPDM, CAD data, requirements, whatever. But we can also have a pull scenario where the SPDM solution is pulling the data out of the PLM. So two different ways of working together depending on the customer situation. So, well, these are the functionalities we have. The use cases at the customers, which we normally see and which we identify to be standard from what we discuss with customers and what we learned and how customers are using SPDM currently, are those 4 use cases which are mainly used. So search and reuse, as mentioned quite often now, the collaboration stuff, and HPC and democratizations. These 4 use cases are used mainly. And just briefly, I mean, search and reuse, as you already heard, we have a local personal storage quite often in use. The tracking of data is not possible. We don't have a change history. And sometimes we are creating a lot of redundant data because we didn't know that we did something before. So the to-be state with this SPDM solution, of course, is all these functionalities which I already described, helping you to get around this one. Collaboration, it's the same. So business processes are normally informal. So there's no documentation. There's just, yeah, you have to do it that way. There's no task assignment really done because it's just an email. Hey, please, can you do the simulation? Here's the data. Let me know what the findings are. So that's the informal process being used here. The simulation data is often not really associated to anything. So to not requirements and not to any activity informations. Doing audit trails is quite difficult today, and therefore regulations and governance is difficult to achieve. So because of a lack of tools being used here, and as you can see here, the process execution dashboards, the communication paths, which I mentioned, these are used for that use case. HPC mentioned, the simulation engineer does have to cover the HPC stuff. So here we have the job submission. It's a one single access point for HPC. We have a job submission wizard helping you to get around it. So we are taking a lot of work off the shoulders of the simulation engineer for HPC. And for democratization, as mentioned, making simulations available for non-CAE engineers. We are able, so for example, if you are a non-CAE expert and you want to do simulations and the system, the SPDM system is set up in the right way, then you're opening the system, you can see 2 icons, just easy access. So you press this icon, then you can see a kind of a property window. So you can define those properties which are assigned here. And then you press the execute button, and the system is getting the results out of the system and sending them to you by email if you want. So that's and everything which is going on in the background was defined and developed and administrated by our simulation engineer beforehand, and then it's provided to you. So that's the way of functionality which you can which you can deal with an SPDM solution. So summary, we are driven by our customer situation. So this digital thread, digital engineering, digital X, whatever you name it, it's driving a lot of demand right now for us and for going for SPDM, because they want to connect the engineering and the simulation world, because they can see we have to improve our process, how to work together. And we want to shift left. So we want to really do more simulations early in the process. So we have to really think of a single source of truth and for simulation data only, and to connect it to the outside world. So we have a lot of customer engagements. I don't know if it's 100 or even more right now. What we have is right now with Ansys Minerva 80 plus customers. Somebody are just using 25 licenses, smaller customers. Others are using 5,000 licenses of SPDM. So a huge range of customers we are dealing with. We have a lot of best practice gathered around those processes which I've discussed. And the deployment which we do is cloud-based. So we can do it on Azure, AWS. The Minerva itself is a web-based application. So you're using a web browser, typing in the address, you get a own license and you're logging in, and that's it. We are spreading all around the different industries, which you can see here: energy, healthcare, auto, electronic, whatever. And to be honest, in the benchmarks, it's going quite well for us, because we are quite often winning because of our usability, open ecosystem. So it seems to be that we are doing the right stuff right now. That's it, Lara.
Great, thank you so much. There was a question from the attendees, but I'm not sure, maybe that was by mistake. I'm just making it open again. Is there any questions from anybody at this stage? I have a question.
Yeah.
Obviously, for us being South Africa and Africa, so we have a lot of startups, and there's a lot of big organizations, but also many are mid-size organizations. So the group of engineers necessarily working in the organization isn't that many. So in that scenario, would you suggest people who are actually startups and new and upcoming company to start using the solution in the beginning as they are developing their capabilities and their design processes? Or how would you position that for mid-sized companies and startups?
I mean, well, as mentioned, there's a data management, a process, and an enterprise integration topic which can be covered. So from a data management point of view, I think it's well, you can't start earliest enough to work in a streamlined way. So if you start early by having your data right, you don't have to clean it up afterwards after a couple of years of running. So therefore, again, as soon as you're starting to work in an efficient way, the easier it is for the future and for your growing path, especially in the beginning. You know, I was a director of a startup as well. So I was starting also quite early with a CRM solution, because I know that we had a huge growing path. So I didn't want to change everything after a year again and after 2 years again, because of the growth rates we were expecting. So therefore, I spent a bit more in that time for the CRM solution, because I saw the growing path. And it paid off, of course, at the end of the day. So here again, if you are, I don't know, 3 to 5 simulation engineers, I would say it's good enough to start with data management topics and get those right, and then you can put everything else on top in the upcoming years, because it's not that you have to start with everything at once. So again, and then if you start small with data management, and then next year you do processes, then it's easier to add those topics on top of a stable data management backbone. And again,
yes,
I would.
If your data management is planned and it's already existing, then it's easier to add more things on top of it and more simulation workflows, I would say, to make it more efficient. So no, that was my take on it as well. And I think that's an important thing that we, as in South Africa and Africa, need to focus on. It doesn't need to be a big organization to start using it. It's actually better to start using it earlier, because then you're not in a problem situation already. You start using it in the beginning once your team is 3, 4, because then you have a process in place for the future.
Yeah. Again, the growing is easier. And from a commercial point of view, if I may say that one, it's based on a named user license price. So if you have 5 people, you're paying 5 people. If you have 10 people, you're paying 10. So the costs are going up with the number of users, means that it's well, quite cheap in the beginning if you only have 5 people, because that's all you have to pay for this named user price at the end. So growing with your
it's actually set up so that you can start as a small company already. You don't necessarily, because you will only pay for the per user situation.
Yeah.
Okay, then that user case. I'm just looking at the questions in the chat. Perhaps in the future, add a user case. And okay, we can send some real world examples, perhaps. And then there's a question about what kind of support and resources are available for users who are new to Ansys Minerva.
I mean, we are offering everything you need to get up and running. So we are delivering support, trainings, implementations. We are not delivering the infrastructure. So that's the only one which somebody has to take care by themselves. So provide an Azure platform, or provide an AWS platform, or provide an own server environment. So the hardware needs to be solved by the customer, but everything else is being provided by us. Our first wish or idea is that the customer at the end of the day can run the system by themselves. So you're not relying on us. So we are not making you depending on Ansys, so that you have to pay us services for years and years and years to do anything more and extend. So we are really training our customers so that if they want to and they have the capabilities, they can do it by themselves. If they don't, and if they don't have resources internally, IT resources, we are able to support them with our partners or by ourselves. So again, everything provided by us or the partners if you need.
Okay, I think that did answer Ndende's question. So thanks a lot for that. Then I would say thanks everybody for attending. It was very insightful. Thanks a lot for offering it to us as well. I'm going to stop the recording now.